Now in this video I'm going to do one of the types of the discrete probability distributions, that is the binomial distribution. Now this is one of the most important probability distributions of a discrete probability distribution, and it is based on the Bernoulli process. Now, what are the basic assumptions to this Bernoulli process, and therefore to thereon to this binomial distribution? Let me talk about them first. The first one: each trial has only two possible outcomes. Now, say for example, from a toss of a coin, we have either a head or a tail. So when there are only two possible outcomes, then the process we can use this binomial distribution. The second one is that the probability of the outcome of any trial remains fixed over time. So which means that if we toss the coin, the probability of head is going to remain same, whereas and also the probability of tail is also going to remain same, regardless the number of tosses we do. Even if we do the 100 tosses, still the probability of head is going to remain same, and the probability of tail is also going to remain same. The third one that it talks about is the statistical independence that we have already talked about. Statistical independence, that is, the outcome of one event is not going to affect the outcome of the other event. A similar case here where the outcome of head is not going to affect the outcome of the tail. So in this case it is going to talk about the statistical independence. Now before I proceed on, let me give you some notations for that we'll be using in case of the binomial distribution. They have a small p, that it represents the probability of success. Then we have this q, it represents the probability of failure. Since we have only two possible outcomes, one is a success, another one's a failure, therefore there are only two. Then we have this r, small r, that is number of successes desired. And then we have the n, that is number of trials taken. So these are the notations. Now let me talk about the probability of r successes in n trials will be given by n factorial divided by r factorial n minus r, and then we have this probability of success raised to power r, and probability of failure, and then the q, that is the n minus r. So this is the way how we actually calculate the probability of r successes in the n trials for a binomial distribution. Now using this binomial distribution, let me calculate the probability of two heads in three tosses or three trials. Now I know that the formula is simple: n factorial divided by r factorial n minus r factorial n minus r, and then we have this p raised to power r and q raised to power n minus r. So now let me put up that I have the number of trials are 3, so therefore this is 3 factorial. Therefore I have the r, the number of successes desired are 2, therefore 2 factorial, and then I have over here the number of trials are 3 minus 2, and I also have this this is a factorial over here, also factorial over here, and then I have this probability of success is 0.5 raised to power r 2, and then the probability of failure is also 0.5. Then I have n minus r, that is n is 3, r is 2, therefore this is going to be 1. Therefore I'm going to get the probability equal to 6 by 2, which is no, sorry, this is going to be, let me calculate it, this is going to be 0.375. so this is how we actually calculate the probability using the binomial distribution. Now note that it is just it is a factorial over here also. So this is the way how we actually calculate the probability of a discrete random variable. Now let me talk about the mean and the standard deviation of the binomial distribution. The mean and standard deviation or binomial distribution. Now the mean is given by mu and it is equal to n into p. We have already introduced the notations, and the standard, this is going to be the mean, and we have the standard deviation, it is going to be given by the n into p into q. So this is the way we calculate the mean and the standard deviation of the binomial distribution. Suppose I am given calculate the mean and standard deviation. So I have to calculate the mean and standard deviation of a packaging machine that produces 20% defectives and the random sample are 10 packages. So I need to calculate the mean and standard deviation of defectives. So now in this case the mean is going to be n is my 10, and the defectives are going to be my p, because I am calculating the probability of defectives, that is going to be 0.2, so this is going to be 2. Now in a similar way I can calculate the standard deviation, that is my n is 10, my probability of success is 0.2, and the probability of failure is 0.8. So this is going to be somehow 1.26. So this is the way how we actually calculate the mean and standard deviation of a binomial distribution.